Okay, you guys got this first part?
Yeah.
Today's date, that's messed up. What is today?
See.
6, good. Anybody need more time on that?
Yeah.
Okay, don't forget that will be this the objective. This is the objective part right here, and this is the pass skill. Those will be on your CYPs. Okay, and a couple of questions right there should be able to answer pretty easy. Okay, you guys good? Okay, on the next side, let's look at this real quick. Right, copy these vocabulary words down. You're going to need to be familiar with. There's 1, 2, 3, 4. You need to copy these vocabulary words down. And on your CYP, I'll put a couple of these on your CYP. CYP will be Monday. We'll do, I'll let you, for people that haven't had an opportunity, most everybody will watch the notes today in your regular class, and then we'll spend the last 30 minutes working on the pair check. Okay? Try to get the front part done and get it graded before you leave today so we get you on the right track. Okay? And then you come back Monday. What do we normally do? We do a worksheet.
Yeah.
And then we do, yeah, then we'll do CYP, okay? You guys warm? Third outline.
Yeah.
Okay, you guys perfect words. Remind me to pass this out today. Everybody need more time with this? Now don't forget, if you guys miss something, you can watch it again. Okay, in the regular class, right?
Yeah.
Okay. Do something that you may even want to do too. The advantage that you guys have over the other classes that you kind of already seen it. So you'll get a pair check in your regular class today, right? And then you can watch the notes and work on your pair check at the same time. Does that make sense? Okay. That may help some of you kind of draw some connections a little bit. All right. Okay. First word, bivariate. What's bi mean?
Two.
Two. Very good. It's like bicycle means two. Okay. What's variate mean?
Yeah.
In this case, it means variable. Good. Hence the term, or hence the definition, data that has what? Two variables. Good. Okay? Data that has two variables. Have you already done a bunch of problems like that? Yeah. In 404, remember we compared hours to pay. If I put 9 hours, my pay is going to be this much hours or this much money, so on and so forth. Okay. A scatter plot is a graph in which two sets of data are plotted as ordered pairs. Okay, you guys know what ordered pairs are, right? It's always going to have an input and it's always going to have an output. Good. And a coordinate plane is going to be basically what? This thing right here. This is a coordinate plane, right? Okay. The ordered pair is basically a roadmap to where I want to plot a point or where I want to plot some data, right? Okay. Line of fit. Line of fit is going to be when points are close to a trend line that can be modeled. Okay. If I had this graph down here, you guys kind of see a line that's going here. I can draw a line right through the middle of those dots. That's called line of fit. Okay? A linear interpolation is a line used to predict. So if I draw this line of fit, we also are going to use it to predict past results, okay, or future results. Everybody understand that? Okay. That based on the data. Okay. This is not, you don't have to write this down. Based on what we just learned, though, if you notice, right here, this line is going up, right? What kind of correlation does that represent? Positive. Now, on your CYP, what I'll probably do is put a picture like that and ask you if it's a positive, a negative, or a no correlation, okay? On this one, if you notice, where's the line of tip look like?
Downward.
Looks like it's going down, isn't it? Okay, so that's a negative correlation, all right? If they're all spread out, kind of scattered like this, and there's no correlation that we can show. It'll be hard to predict when everything's all scattered like that. Everybody clear on that? Okay. All right, so going to the next slide, going back. Negative or positive correlation? Negative. Good. Pretty easy, isn't it? If you notice, there's a whole bunch of information here, okay? Don't just skip it because it's really wordy, all right? If you just read the instructions, the graph shows the average number of students per computer in Maria's school. We just need to determine to show the positive, negative, or no correlation. If there's a positive or negative correlation, then we describe its meaning. What's happening here? If it's a negative correlation, what's happening with the data? Yeah, as the years increase, okay, the number of computers per student is what? It's dropping also. Okay, that's the correlation. That make sense? Can I predict in 09, if I put 09 over here at the end, can I predict what's going to happen in 09? Yeah. Based on the relationship, in 09, there's probably only going to be maybe 2 to 5 computers per student, or students per computer. Does that make sense? Okay. This stuff is really good for like business owners, you know, to draw correlations as the years their sales go. You know, they can kind of predict as the year goes during certain times of the year whether they have the best sales. You know what I'm saying? Depending on what type of business you are in, the summer may be better months than the spring. Okay, or the spring may be a better couple months than the winter. Okay, I can show that correlation with a scatter plot. Is everybody clear on that? Okay, and that will kind of help me determine how much money I can spend throughout the year. You know, the graph shows the number of mail order prescriptions. Determine whether the graph shows a positive, negative, or no correlation. What is that one? That one's pretty well defined, isn't it? If you notice all my points, my dots do what? I mean, they're all going to pretty much fall on that line. Okay? So as the years increase, what's happening? Yeah, the number of prescriptions are being made or sold, okay? Pretty easy stuff. Okay? All right, this should be on the handout that I just gave you. What you're going to have to do, what you're going to be required to do, is basically those 3 examples that we just showed, you're going to have to do something very similar to that. Okay? Now, the good news is you can have different answers a lot of times. Okay? They're going to vary, but they're all going to be pretty close together. Okay, population table shows the world population growing at a rapid rate. Identify the independent and dependent variables, then make a scatter plot to determine what relationship, if any, exists. Okay, what have we said about the independent variable? It's always what? Which variable is it? It's always X, right? It's always my input values. Write that down. This is my independent. Why do I need to identify the independent variable? Independent variable always goes on which axis on my graph? It always goes on the bottom, on X. Is everybody clear on that? Okay. The dependent variable, therefore, is going to be what? Y. Okay. That's going to be Y, and this is going to be X. So now, you guys understand that this is what? Order pairs. Very good. And now look at my graph that I made. Notice it kind of goes from 0 to what? What is that? 0 to 1,000. So what am I missing on there? What should I have down here at the bottom? I should have a little squiggly line, shouldn't I? What's the squiggly line represent? Yeah, I'm skipping a whole bunch of data, right? Skipping a whole bunch of values, so my graph may be a little off. Everybody clear on that? Okay. So 1650, I had 500 million. So where's 1650 down here at the bottom? What would halfway between these two?
Right there, between those.
Right between those and then maybe a little over? Okay, does it have to be exact? No, because it is a scatter plot. It's just ballpark. All right? It's just ballpark. We want to get it fairly pretty close, okay? Yeah, exactly. So now we can go ahead and do the rest of them. 1850 is same thing, about right in the middle. Go up to 1,000, about right in there. And then 1930 is just a little over 1,900. Go up to pretty big jump right there. Okay, 1975. Go to 4,000. Okay, and then 2004. About 6,400 be right in there. Okay? So my line of fit would be where? About right in there. Okay? What year do you think this company probably started? Very good. 16. Look at my graph. Over here, right? Okay. Okay, so now, that was step one. Step two, sorry. Step two, we just did that. We just made a line of fit, didn't we? Okay, that was step two. We just draw the line. No one line will pass through all of the data points. If you look at my graph, it's not going through all the points, is it? But it's pretty close to right down the middle. Okay, draw a line that passes close to the points, the line that fit is shown. All right, step three. Step three is probably the most involved part right here. Okay, because what we want to do now is we want to take the data like we did in 4.4 and 4.3, and we want to write an equation that will help me predict values for later on. Okay, so step three, write the slope-intercept form equation on the line that has the fit. There's the slope-intercept form. You guys should be pretty familiar with that by now. Okay, everything that we've done at this point, we're trying to tie in. Line of fit shows passes through the data points 1850 and 1,000. That was one of my order pairs, right? And 2004, 6,400. So we want to find the what first? Find the slope. Okay, so my points are, this is my x of 1, y of 1. Label that on the sheets that I gave you. X of 2, y of 2. Okay, so I got 18. Whoops, I already messed that up. I got 6,400 minus what? 1,000 over 2004 minus 1850. Okay, what's that end up giving me?
154 and 5,400.
You sure? What's my top number?
5,400.
5,400, good. And my bottom number?
154.
Okay, now, I want you to notice something about the slope. Those numbers are pretty big, aren't they? Okay, now, remember, on our graph, it's just a line of best fit, isn't it? You guys listening? I'm trying to make things easier on you, okay? my slope does not have to be right on perfect. Are you with me? I don't want to have to sit here and mess with these big old numbers. You guys want to do that?
No.
Okay. So let's simplify this. And here's how I want you to simplify it. I'm going to take that top number and I'm going to divide it by the bottom number so that it makes my bottom number what?
No.
Makes it 1, right? Okay, so what's 540 divided by 154?
30.
That's 500, no, that's 5,000.
Do it on your calculator real quick.
3.5.
How much?
3.5.
3.5? 06? Okay, so now, do I need to use all of that?
No.
No. I'm just going to use 3.5.
But isn't that 5,400?
No.
I don't know. I asked you guys. But 6,400 minus 1,000.
5,400.
Okay, so now do it
Change the
again.
decimal to the right.
Just one, so it'll be 35 on it. Okay? But again, what am I going to use? Am I going to use all 4 of those numbers?
No.
Okay, this is pretty minute right here, this part, isn't it? So I'm just going to use 35 for my slope. This is what I want to use right here. So now all I got to do is this. This one slope good. So I have at least 1 point.
Yeah.
Okay, I'm going to use the one that I already labeled. So that value is going to go there. And that one will go there. Y minus 1,000. What am I going to put for M?
35.
Nice. And then X minus 1850. You guys with me so far? Okay, see that? Now I just got to do what? Just simplify and distribute, right? Y minus 1,000 equals 35 X.
Minus 64,750.
What?
35 times 1,850. So you have to plus 1,000.
Very good. Plus 1,000.
Oh,
65,750.
Minus, wasn't it?
Yeah.
Actually be 63.
3,000.
Yeah, 63,750. And this is my answer right here. Okay, now, what do you suppose this minus 63,750? Why do you suppose what does that represent? Think about it, if I'm a company, I automatically start out, in most cases, I already start out in the hole, don't I? Think about it. Because if I'm starting a company, I'm going to do what first? I'm going to borrow money. I'm going to buy all my supplies. I'm going to buy all my products
higher.
to do what? To sell them. Okay? I'm going to sell them at a higher cost than what I paid for them. That's how I make money, isn't it? Okay? Now, what influences those prices? Supply and demand. What else? What's the number one thing? How are you going to get this product to your store? You got to ship it, don't you? What's been crazy here nowadays? Gas has been what? It's been really high and it's been really low. Okay, it's come back down a little bit, hasn't it? But when the gas was really high, products, what happened to everything? Everything went up, didn't it? Okay? That's because you're having to pay for the gas too to get it there. Does that make sense? So if that goes up, then you gotta charge more for your product. Makes sense, doesn't it? Okay? And that's probably where the minus 63,000 came in. I probably already started in the hole because I had to buy all the product before I could sell it, okay? Or manufacture it or whatever I did. Any questions on that?
No.
Pretty good stuff. If you own a business someday, it might be useful. All right. Now, I know the EOY test will ask you a couple questions like this, and these are pretty tricky, so I want you to pay real close attention. We want to use this equation, y equals 8x plus 1104. Okay, in this equation, what is an x here? It is the years since what? Okay, so here's the key word. Is since. Okay? So if I say 19, I want you to tell me in 1990, okay, what were the number of bachelor's degrees? How many years since 1988 is that? You got 89 and 90. So that's how many years? 2. This is one of the most commonly missed problems on the EOY. Okay? Because they don't you guys got to understand that it's since 1988. Well, if I use 1990, then that's 2 years. So 2 goes where? Right in there for the x. You guys see that? Okay. In this case here, when you use the equation y, where x is the years since 1988, y is the number of bachelor degrees in thousands. Okay. So when I get an answer, what am I going to add to it? How many zeros? 3. 1, 2, 3 is thousands. Okay. Hundreds would be what? 2. Okay. To predict the number of bachelor's degrees that will be received in 2015. Okay, so how many is that? 2015 minus what? 1988. Do that on the calculator.
27 years, yeah.
Okay, so it's 27 years since the beginning, right?
Sure.
Okay, so now all I have to do is plug it into my equation. 27 for x. Okay. When was 1104? Very good. 1104 is my starting point, right? When is my starting point? So in 1988, that's what I started with. Okay? So 27 years since then, this is going to be how many degrees were given out. What's 8 times 27? 116? Okay. 216 plus 1104. 10 carry 1. 10 carry 1. 2. Now, is it just 1,320 degrees?
Add 3.
It's got to add what? Makes more sense, doesn't it? Think about all the universities across the nation. Okay, that would be what? 1.3 million. That sounds more like it, doesn't it?
Yeah.
You think about all the universities. Here's another thing that you got to remember on these problems. You guys listen to me. You got to think about, does it sound reasonable? Okay, does my answer sound reasonable? When we just had 1,320, was that reasonable? If I think about all the colleges that are graduating, or are they just giving out 1,000 degrees? No. So that doesn't sound reasonable, does it? It doesn't sound logical. 1.3 million now, does that sound reasonable? Yeah. Okay? Gotta remember that. Take that into consideration. Yeah, that's a lot. Okay, pair checks. How many more do you guys need? Two? Huh? All you guys got one? Really? I have none. Oh, did you get that quiz done, chapter 4 done yesterday?
No, I got this power. I got to take it to power.
Okay, we need to try to get that done. Okay, this one's on your prayer tick, isn't it?
Yes.
Okay. So, again, these are my X and Y's, my inputs and outputs, right? Independent, dependent, right? Okay, so those are my ordered pairs. I'm gonna start here at 0, which is right here, and go all the way up to what? Just a little bit over 5. Okay. It's already messed up. Okay, so about right in there. 1 and 530. I'd probably put that like right under the 5.4. 2 and what? Right in there, maybe run over just a little bit. 3 and 580. And 4 and 6. That's gonna be pretty close. Maybe just a little bit under that. You understand? Right in there, maybe. All right in there. Sorry, Daniel.
Yeah.
Oh, but you got the data, don't you? Got the data.
Yeah, we got that. It says.
Right, that's what you gotta show. What are the two things that you need in slope intercept, or just slope intercept form? You need a slope, and you need the B, right? Now, we're gonna get the B through point slope. But on that one problem, on problem 3, okay, write these points down. You got 0 and $5.
So number 3.
Yeah.
Okay, and then I would put 4 and $6 because those are pretty close to being even. So I'm going to make this my X of 1 and my Y of 1. Now I'm not going to use 508. What would I use? Just 5. Okay, and then you got X of 2 and Y of 2.
So you do top, the lowest and highest?
Probably, yeah. Here's what you gotta think about, Josh. Do it like this. I wanna get as close to whole numbers as I can possibly get, right?
Yeah.
Okay, this one is a lot closer to 5 than that one is. You see what I'm saying? Okay? Same thing down here. The $6 would be more, it's a lot closer to being a whole number than, say, 5.881, okay?
Yeah.
The idea is, now, you won't use the first one and the last one in every case. Sometimes you'll use the second one and the last one. So maybe the first one and the third one, you get a pretty good distance there, okay? All right, so now, going back, you guys can remember those numbers for me. All right. Okay, so now, we said our numbers were what?
0 and 5.
5.
0, 5, 4, 6.
Okay, so 6 minus 5, 4 minus 0,
4.
so 1 over 4. Okay, now, what point? Here's where it kind of gets a little easier too. What point would I use for y1, x1?
The first.
Yeah, I just use the top one. Okay? Now you just plug all your stuff in. Y minus 5 equals, now, I'm going through your papers, I'm seeing you guys do a lot of this. Okay? What's a 4 times x?
1/4 x.
What's a 4 times 0?
0.
So don't put anything out there. Okay? Now, and the reason why I say that is because now you know that you're going to do, what are you going to do next? You're going to move something, right? I'm going to move
What's 5?
the over there, and it's going to change into a
11. And then you're done.
I am, unless it asks me like a different year, which it doesn't in this case. Okay? Are the bells messed up?
Is it supposed to be right?
Oh, 5, yeah. 35.
Yeah.